Hello, am I audible? Papia, can you hear me?
Yes, Samantha, you
Oh,
are audible.
okay. I thought, I, okay, it's okay. Okay.
Hope I'm audible properly for you.
Yes.
Okay. So
Yes,
it's 12:06, and I would like to request all of you to have a look on your computer screen and be attentive for our webinar today. Thank you so much for joining. Welcome and good afternoon to everyone present here. And we will just start our webinar today. And uh, maybe the student participants is late today a little bit. I'm really sorry for that, Mr. Hitesh Mehta, because there is unexpected exam notice they have received. So maybe for that, student attendance is a little less. So uh, So I would like to request all of you, please mute yourself and please do unmute yourselves if it is required. Also, I would like to request all participants kindly mute yourself during talk, and you may write your questions in chat box, or please do share your thoughts with us verbally at the end of the lecture. So uh, our distinguished speaker, Mr. Hitesh Mehta, all participants who are mostly faculty members, students, and our respected dean sir is not here, but I would also like to thank and means some virtual presence is there. If he calls me, just before 1 second and say sorry to a speaker as he couldn't join today right now because of some crucial meeting. And also, I would like to welcome our HOD of Physics, Dr. Momita De, Madam, our senior professor, Professor Aparajita Bhattacharya, Madam, and whoever gathered here today for this distinguished lecture of Academic Industry Meet 2022 of Department of Physics. So I would like to welcome all of you and thank you for taking the time off to join us in this deliberation. So without delay, now I would like to request our Associate Professor of Department of Physics, Dr. Tamal Mukherjee, to introduce our speaker. Over to you, sir.
Thank you, Papia. Am I audible?
Yes, perfect.
Okay, thank you. So it is our great pleasure to welcome Mr. Hitesh Mehta as our speaker today. Mr. Hitesh Mehta is the co-founder of Fiber Optical Technologies Private Limited and managing director of Eagle Photonics, a company working in the area of telecom services. He has 27 years of experience in fiber optic communication and telecom industry, ranging from production, R&D, business development, project management and consultancy. Hitesh Mehta received his MTech degree from IIT Delhi in the year 1995. He started his career with Optical Telecommunication and later, during his tenure at TVS, he established Nortel Networks Component Division, Virtual Photonics, and Lightwave Micros Photonics business. He co-founded Eagle Photonics in 2002 and Fiber Optical Technologies in 2008. Eagle Photonics has created its own space in area of telecom system integration and training. Hitesh Mehta is past chairman of IEEE Bangalore section. He served as coordinator for continuing education program for working professional at Indian Institute of Science, Bangalore for 4 years. Hitesh Mehta received DST Lockheed Martin Gold Medal for Innovation, Alexander Graham Bell Award for Innovation, Economic Times Power of Ideas Award. He has filed 12 domestic and international patents. He is fellow of IETE, senior member of IEEE, and member of Communication and Photonics Society of IEEE. So with this, I would like to welcome Mr. Mehta to this session today. And since people are waiting to hear from you, so I don't like to delay any further. So over to you, sir. I would like to request you to start your presentation now. Thank you, sir.
Thank you, Dr. Tamal. So I prepared my presentation keeping students in mind because subject is a career in the fiber optic industry. So I thought students would be interested to know what are the career options after doing this physics. But I believe there are not many students. But anyway, faculties are there and they can pass on the information to the students who are interested. Okay, so I'll just share my screen. So yeah, so Papia asked me to speak something on the career options for the students after doing some bachelor or major in the physics. Okay, so there is I mean, there is a thinking in the students that there is no career after doing the physics. Mostly of the careers are there in the IT or after engineering, but it is not like that. After physics also, there are a lot of career options if you carefully choose and carefully work towards that, right? So what are the options available for the especially for physics student and especially in fiber optics, because my field is of fiber optics. Fiber optics is a part of the physics. So after physics, you can easily learn fiber optics. I think it is a part of the curriculum as well. Okay, so many teachers are there, many faculty members are there, and they can ask me during the presentation. There are a lot of discussions will happen on the different career options. So faculty members are welcome to ask, interrupt, and ask anything, any questions in between. Okay. So yeah. So why I will just limit. There are many options after physics, but I will limit my discussion around fiber optics. So fiber optics is a special portion of the physics, a special portion of the optics, right? And there is a lot of demand in the fiber optics field in different arena. So optical fiber, I think all of you students know that optical fiber works on the principle of total internal reflection, right? And uh, and optical fiber is just a medium, but surrounding optical fiber, there are many technologies. We make the cable out of optical fiber, we make the systems. So yeah, I'll just discuss all these things. Yeah. So I am specifically listed out the keywords. All these keywords, these are basically property of the some physical parameter. It's a physics, total internal reflection, Snell's law, mode, reflection, numerical aperture, group velocity, mode field diameter, scattering, attenuation, dispersion. All these things are part of physics, which no engineering students would know in detail, but physics students can know in detail. And why I'm listing this thing? Because these are the parameters which affects many systems. Because ultimately, when we go to the industry, there are many parameters. If you know this thing better, you can solve many industrial problem, right? So, which are the sectors where you can where knowledge of fiber optics will help is the components manufacturing. This I am talking about telecom industry, where I have a lot of experience all over all these years. Now I am focusing more on sensors, but in telecom, in the components manufacturing, in the telecom services, in development, research, and planning, a lot of fiber optics knowledge would come handy. If you go to the sensor field, you go in the design, manufacturing, planning and development, in research and applications. Okay. So basically, after all the education, you have three options, right? Either you go to the teaching or research, or teaching and research, or you go to the industry. And third option is the entrepreneurship, which is a buzzword nowadays. Why to take a job? You can give the job to the other people. If you know the principle, if you know in the depth, and you can use that application for some real life problems. Okay. So if you know the optical fiber well, you have options in this industries which I have listed out. There are many more, but I have just listed out big companies like STL, Sterlite Technologies, which is the biggest manufacturer of optical fiber, not only in the India, over the world. Sterlite is working in multiple countries, supplying to the multiple continents. So there is a lot of opportunities for the optical fiber knowledge, because they are large manufacturer of optical fiber and designing new optical fibers. Then we have Finolex, Usha Martin, HTL, Himachal Futuristic. All these are the industry who are dealing directly into the optical fiber and related components. Then you have option in the optical fiber networking and services industries like Reliance Jio, Cisco, Tata Communication, Infinera, Tejas Network, VI, Airtel. All these people are using optical now. Without optical fiber, no G is possible. 4G, 5G, you're talking about the 1G, 2G, 3G, all this G, basically backbone is optical fiber. So you require optical fiber knowledge, right? This is the industrial option. Then suppose you want to go, one option is which most of the physics students are choosing, is the teaching and research. That everybody knows that teaching and research is low hanging. You can immediately get into that. Second option is the industry. But apart from the industry, suppose you want to create your own industry. So entrepreneurship is a one better option where you can have some idea. You can use your physics knowledge and make some product or services which is useful for the field. India is a big market. We have 130, 125, 130 crore people, and there is many options for the products. We are not making much products. We are mainly in the services, but we can make many products. Unfortunately, in India, we are not manufacturing any laser. We are not manufacturing any receivers. We are not manufacturing any optical components. Very few optical components. But why not? If you have knowledge, there is a funding options available from the government, from the private equity, and you can use your knowledge for your earning as well as for the country. Then there are options in the government organizations, in the DRDO, in the Bharat Electronics, in BSNL, in the RailTel. In the research, in the government side, you can go to the Samir, you can go to many DRDO labs, even ISRO also. In fiber optic sensor, there are some industries like fiber optic sensing solution, that is our industry. Then Bosch, there. Honeywell also, I not listed, but Honeywell is also working in a lot of sensors. Okay. Why there is option for fiber optic? Only you have to carefully apply your knowledge and you have to carefully look at that. And most important thing is that you should have very in-depth knowledge, right? If you have superficial knowledge, if you just pass the exam, you can't get many options. But if you know in and out of the fiber optics, you have many options available. You can see a lot of fibers. How do this thing will be handled without knowledge of the fiber, right? Over 5.6 lakh kilometer optical fiber cable is laid under Bharat Net project by government. 1.71 lakh gram panchayats are connected to the optical fiber, right? HFCL, the complete broadband connected in all gram panchayat. There are many, you can see the news items. A lot of optical fiber is being laid, and without the knowledge of optical fiber, how can you handle this thing? So there is definitely a lot of options for the fiber optic engineers or fiber optic scientists. Then I was talking, this is I talk about the telecom and the research. Then there is a new field which is coming up. In the future, this field will grow very fast. The optical fiber sensors. Okay. So what is optical fiber sensors? Optical fiber sensor detects changes in the light guided through the optical fiber which is affected by the action of physical, chemical, biochemical, or any other parameters. Okay. So sensing parameter we use as optical fiber, we have source, we have detector, right? Very basic, the very fundamental principles. But if you know how to use that principle, you can go into industry, you can have your own industry as well. Okay. So what fiber optic sensor can do? It can measure the temperature, pressure, strain, displacement, acceleration, flow rate, vibration, chemical concentration, electrical and magnetic field, rotation rate. Okay. So I will just tell something detail about the optic sensors because this is upcoming field and students should look at that. Right. One thing I want to say that only knowledge of physics would not be enough in many of the industry. Apart from the physics, you should know a little bit of the electronics because most of the components, most of the devices are optoelectronics. It's not a purely optics, right? To use the optics, you require electronics as well. Then only you can get the some good device or system, right? So I would request faculty members that when you are making a curriculum, you just see that student gets some added knowledge of the either electronics or artificial intelligence or some deep learning, signal processing. Some knowledge would be always be handy apart from the basic physics knowledge, because ultimately industry requires for the application, and the application is not possible without the help of the either electronics or software, right? So this is the input I want to give to the curriculum makers, right? So now I am looking at the many optical fiber sensors. All these sensors are possible only with the help of the electronics. Just fiber cannot do anything. Even fiber measure something, how you can display, how you can take the data out. For that you require either some electronics or software, right? So fiber optic sensors are based on the sensing side. It is interesting of extreme sensors based on operating principle, intensity modulated, phase modulated, wavelength modulated, or polarization modulated, right? We require a lot of physics to understand this based on the application, physical sensors, chemical sensors, or biochemical sensors. So here I have listed the type of optical fiber sensors, right? Now interferometry is a very celebrated principle in the physics or optics, right? Based on the interferometry, we can make the Fabry-Perot sensors, May-Gender sensors, magnet sensors. Now, based on the scattering principle, right? You know the scattering about Rayleigh, Raman, Brillouin scattering. Based on that, we can make the Rayleigh distributed sensor, Raman distributed sensor, Brillouin distributed sensors, right? Then you must be knowing about the fiber break grating. I don't know whether it is being taught into physics curriculum or not, but it should be taught. So based on the fiber break grating, you can have long period and tilted fiber break grating sensors. Now, fiber optic sensor network, if you see, there are three types of fiber optic sensor network we can build. One is based on the point sensing. Point sensing means sensor will measure only at the one particular point, right? Quasi-distributed sensor means it can measure at multiple points in the network, but not all the points. And when we talk about distributed sensors, then it can measure each and every point of the network on optical fiber, using optical fiber. This type of sensors are available. So point sensor, everybody knows that when you put optical fiber somewhere, it measures something, it is point sensor, only one point. But quasi-distributed sensor, you see about the principle of the fiber break grating, right? So if you put some if you make a grating structure, how we make the grating structure on optical fiber? We change the refractive index periodically in the core of the optical fiber. How we change the refractive index? Using the high power UV laser beam. We just shine the optical fiber at some points periodically. So what happens? Fiber is having grating like structure, means high what is called high refractive index, low refractive index, low refractive index, high refractive index, like that periodical structure, right? When you make periodical structure, fiber will become like a band pass filter. It will allow all the wavelength except few wavelength, right? So you can say, you can see here, if you send the light, only one particular wavelength band will reflect, other will pass through. Okay, and these are very beautiful properties. Now this wavelength which is reflecting, right? The wavelength will change with the change of the parameter. If you put some pressure on the fiber, if you put some strain, if you change the temperature, the reflected wavelength will change. So that we can use in the sensing, right? So study of the fiber break dating also is very useful if you want to go into the sensor industry. So here I have shown that how due to tension and compression, wavelength will shift in fiber break dating. And how with the temperature, wavelength will shift. Okay. So basically what you are doing, you are using the principle of physics and converting into some useful entity, right? Ultimately what people need, they require some applications, right? So if you use this principle and they can't, they don't know anybody. If you ask the normal people, they don't understand what is the wavelength shift. But if you calibrate that and give some GUI, you give some device where they can see the, okay, now the temperature is 30 degree, now it's 40 degrees, 50 degree, they will be very happy, right? But behind that, that is a physics. So this is a fiber break dating system. Okay, how it looks like. And now you can see some displays there, some screen is there, then some box. So as I was telling earlier also that you require some kind of knowledge of electronics as well, because ultimately optics work with the electronics. Then we get the optoelectronics devices, right? So we get the data, then we require some signal processing. So we signal process and then we can convert into some useful information. Okay, this is how the fiber optic break dating sensor system works. Operating principle I already explained, but here one more pictorial presentation you can see. Applications. There are many applications. One is like intrusion detection security, because due to the any kind of strain or the optical fiber, there is a change in wavelength and we can know. So if you are putting, see this thing on some border and somebody is coming, we can immediately find out that somebody is trying to intrude. This is one of the application. What happens in distributed sensors, that all optical fiber, full optical fiber, every point is become sensor. And that works on the basically scattering principle, and we can use for distributed temperature, acoustic and strength sensing. And what are the principle we use behind that? There are three types of scattering happens. If you read the optics, the physics, you know that in optical fiber, whenever light pass through, it suffers through the three kind of scattering: Rayleigh scattering, Brillouin scattering, Raman scattering. Okay. So based on the this thing, Rayleigh scattering happens due to the basically the structure of internal structure of the optical fiber. Brillouin scattering is basically due to the sound. These are sound vibrations, which changes due to the external strain or acoustic disturbance. Raman scattering happens basically due to a change in temperature. All this principle, if you know, we can make device based on this. So just some pictorial presentation that how the system we work, how we use the principle to make some device out of this using the Rayleigh and Raman distributed sensing applications. Okay, again the pictorial representation of Brilliant distributed sensing. So what happens when there is some acoustic change, acoustic disturbance, we get the Brilliant scattered light. And if there is some temperature disturbance, we get the Raman scattered light. If we can separate out that light from the original light, we can get the useful information. That is a sensing. So what happens in distributed fiber sensing? Whole fiber is become sensor, right? You don't have to put anything extra. You have to just put device inside the fiber. You don't have to do anything, and you use a normal optical fiber. What happened in the fiber grating fiber? We are putting we have to make the gratings. Here you don't have to do anything. Whole fiber becomes sensor automatically if you can measure the Raman and Brilliant disturbance, right? So this is the principle, how it works. Laser goes to the optical fiber and there is a disturbance. There is a backscatter light, which we can take on the detector. How we do that? We use a circulator. What is a circulator? Circulator allows signal to pass only in one direction. So whatever light going from the laser, it can go through. But whatever light is coming back, it cannot come back. It will just circulate to the other port, where we can take the backscatter light on detector and then we can analyze that. Then distributed temperature sensing, there are many applications. Pipeline temperature monitoring, leak detection. In the very high sensitive area, we can measure the temperature shift or change, right? Then the vehicle traffic on roadway, about buried pipeline. Okay, so you can see if a pipeline is buried and we want to protect a pipeline, we don't want pipeline to destroy due to the weight. So if empty truck is going, you can see the peak, and when truck is full, you can see the peak, right? So if there is some certain weight which is not allowed beyond that, so we can measure this thing using the sensor system, fiber optic sensor system. If there is an abnormal strain, we can restrain that. Then earthquake monitoring you can use using optical fiber sensors, right? So there is one example where people have measured around 3,000 kilometers, 300 kilometers away this earthquake, because this seismic wave that passes through, that is acoustic wave, and if acoustic we can measure. And optical fiber is very, very accurate in that terms. Then distributed acoustic sensing we can use for the intrusion detection. We can use on fences, on the walls, on the picture galleries. You can use for the border security. You can use for the airport security. You can use for refinery security. Okay. Now, if you see the fiber optic sensor system and if you compare with the fiber optic telecom system, they are not very much different in the architecture. Basically, we require laser source, we require detector, we require optical fiber, and we require some signal processing. Both are the same. Only thing in the optical fiber telecom, we are sending large data from one place to other place. We are not doing any sensing kind of thing. In the sensing system, instead of transmitting the many data, we are just signal processing and convert into the useful information. Okay. Now I am coming to interferometric fiber optic sensors. Right, interferometry is the principle which every physics student would know, right? So why I am showing in detail? Because using the interferometry principle, we have made some device and we have created one company using that. So only one interferometry principle. You can create more companies. So what we have done, see, I just tell about interferometry first. Okay, what is interferometry? You know that there are many different kind of interferometry, you know, right? So I'll just tell you next slide. Yeah. So you know the two beam and multi-beam interferometry. I will not go into detail of the physics. You must be knowing this thing, or you must be taught in your degree or degree level. I'm just telling in fiber optic interferometry how it works. You know about the Michelson interferometer and Madge interferometer. They are basically two beam interferometry. And if you know the multi-beam interferometry, which is a Fabry-Perot interferometer, ring interferometer. Now what we have done, we use this principle. When we make the interferometer in fiber, it becomes very, very sensitive to the acoustic disturbance. So if we make interferometer, and if anything is happening near optical fiber, and there is some vibrations, it gives some kind of alarm. If we compare, if you have two arms of the interferometry and one arm and second arm, this phase will disturb when there is some acoustic disturbance happens nearby. And if we can measure the difference, we can detect the intrusion. This simple principle we use and made one device and created one company called Fiber Optic Sensing Solution based on that. But you can see our product. This is our product which we made using the basic principle of interferometry. Okay, and what this product can be used? It can use for the perimeter detection. It is completely passive sensor. It is zone-based system. It is using distributed acoustic sensing. It can in real time. It can give alarm and alert and warning. It can be used over ground and underground deployment. Over ground, if somebody touches the optical fiber, there is a disturbance in the phase and we can detect it. In the underground, if somebody is walking, somebody is digging, some vehicle is coming, we can measure a disturbance. Okay, and of course, we have used a lot of electronics and software. So that's what I am insisting that only physics will not help. You require some knowledge of the either electronics or software to make the complete applications. Okay, what are the applications of this? Perimeter intrusion detection, third-party interference, power cable monitoring, traffic monitoring in the road, railways and subway, seismic activity monitoring, subsea cable monitoring, okay, asset integrity, oil, gas and water pipeline monitoring. Okay. So this is how our system practically works. We divide into different zones. In different zone, we have different interferometer, which can detect if any kind of activity, unwanted activity is happening. Okay, so this I will just show one video. This is the presentation and
Thank you very much, sir.
I will just show the one video quickly. Yes. So what our product we have developed, how it works, so people will understand better. Okay.
Faces several security issues, and prominent among them are physical security breaches, such as infiltration.
Can you say my video?
Cross-country terrorism activities.
Yes, sir.
Sabotage of critical public infrastructure. Poaching activities in forest, wild sanctuaries, and many more. Fiber Optic Sensing Solutions introduces a Make in India product, Fiber Optic Perimeter Intrusion Detection System, FOPIDS. A state-of-the-art fiber optic technology-based solution to detect real-world security threats. FOPIDS is a zone-based system where a perimeter length is divided into smaller sections, and each section is known as a zone. The length of zone can vary dynamically from few meters to kilometers.
You can see the audio and video both?
Yes, sir. Audio, video, both.
Yes, sir.
Okay, fine.
The FOPIDS network uses single-mode optical fiber cable which is completely passive in the field as it does not require any power supply in the field for its operation. FOPIDS receives sensed vibration signals from the zones instantaneously, and interrogator generates alarms immediately without any delay, making it a real-time system. FOPIDS can be integrated with third-party peripherals such as CCTV, thermal cameras, monitors, SMS modules, alarm units, floodlights, and many more, creating a complete integrated surveillance network. Single-mode optical fiber cable is used as the sensor as well as lead cable in FOPID's network, making it immune to EMI and RF interference, and also it is not affected by lightning. This results in stable performance of the entire solution. Optical fiber sensor cable can be deployed in several configurations, such as in different type of fences, walls, and also in underground applications, either separately or all combined, according to the criticality of the site to be protected. Fence deployment. Wall deployment. On top of the wall, on the wall, or inside the wall. Underground deployment. This will keep the optical fiber sensor cable hidden from the eyes of the intruder, making it invisible to the potential intruder. On occurrence of an intrusion at the perimeter, a real-time alert will be generated at the control room in the form of alarm signals like buzzer, LED, and zone map indicators. Different types of intrusion activities in overground and underground deployments can be detected by FOPIDS. Climbing fence, cutting fence, putting ladder in wall, drilling wall, walking or running on ground, digging manual or machine. Fiber optic perimeter intrusion detection system is classified into two variants: Safe Fence, Safe Max. Safe Fence hardware supports two zones: a standalone unit embedded with touchscreen for software monitoring. It is suitable for monitoring smaller perimeter lengths. Safe Max is a bigger hardware which has larger capacity of zones and thus covering a larger perimeter length. It is a 19-inch 4U rack-mountable, scalable, modular unit. One unit of SafeMax can handle 16 zones in fully loaded configuration. Multiple SafeMax devices can be cascaded together, thereby increasing the length of fence under observation. The interrogator's Safe Fence and SafeMax are connected to a dynamic user interface, FOPIDS Manager, through which the zones are monitored in real time. FOPIDS Manager gives the facility to draw zone lines and include map images as background. Display of intrusion alarm by color change of zone lines. FOPIDS Manager displays the intrusion details with date, time, zone of alarm, and much more during the intrusion occurrence in the log. Capacity to add multiple projects and devices at the same time. Fiber optic perimeter intrusion detection system detects and alerts all kinds of intrusion activities happening in and around the perimeter, thus protecting critical structures from threats and sabotage activities. FOPIDS can also be integrated with camera surveillance, alarm systems through TCP, IP, or NONC dry contacts provided within FOPIDS device. Single-mode optical fiber cable is used as the sensing fiber and lead cable in the field deployment of FOPIDS, which are easily available in the market, along with passive field components enclosed in IP65 enclosures, assuring water and dust protection in all kinds of terrain and environments. FOPIDs can play major roles in critical infrastructure security and monitoring in several sectors, ranging from perimeter applications like larger and critical perimeter applications such as country borders, prisons, airport perimeters, nuclear power plant, oil and gas depots, oil and gas cross-country pipelines, cross-country telecom infrastructure, to smaller perimeter, such as armament depots, defense establishments, VIP residences, embassies, Vidhan Sabha complexes, farmhouses or bungalows or isolated buildings, religious places of worship like churches, temples, gurudwaras, and mosques, schools, bank lockers, strong rooms, research facilities and laboratories, unmanned BTS towers, unmanned substations, windmills. For all the security-related concerns, we are offering a one-stop solution with our product, FOPIDs, Fiber Optic Perimeter Intrusion Detection System with 24/7 smart surveillance.
All right, so yeah, I wanted to show that using only the interferometry principle, if we can create one product in one company, so like that students also should learn some principle, use some principle, use for some real-time application, and they can create their own industry. So I have kept some time for the discussion, question and answers, and somebody want to discuss anything regarding industry. That's what I have kept some few minutes for that. So please feel
Yes,
free
sir.
to ask any questions.
Yes, sir. Thank you so much, sir. Because I have a bit knowledge on this field as I have done my research on this field only, but you can understand still we have some gap of knowledge between what industry want, what actually the problem, and what we are doing in our research lab. So after your presentation and particularly this video, really, I think our students also very motivated for this field, whatever you show. And I'm really thankful for this endorsement of academia industry connection. And I must say now that I think our India is in that time, we should make the bridge between this academic knowledge and application area. When one physicist or one electrical engineer, they should not ask for external help for any household small technical difficulty at least. So this is a small step, I think, today we just take to develop, to endorse the skillful learning to extend career path for students of physics or maybe for others. So it was really very much informative. As also Mehta sir told us, this is a question and session is open. So I would like to request if you have any queries,
Yeah,
especially from
anybody, they can
students.
unmute themselves and
Yes,
ask.
you can ask any student or anyone. Uh,
Uh, Good afternoon, sir. Sir, I'm Deep Chaudhary. Sir, I want to ask that how much optical fiber sensor is commercialized among common people?
Yeah, a lot of already I have shown one application which we have commercialized. Then there are optical fiber sensor are used in large number in oil and gas industry for pipeline monitoring. Already being used for last 6-7 years. For the border security also it is being used for the last decade or so. And recently we have done some project for the Tata Steel using the fiber detecting sensors. They also want to use fiber detecting sensor in a big way. So thing is that awareness is not there in India. We are behind the world in using the optical fiber sensors, but in the developed country, it's being used in the very, very large quantity. So India also, if we make people aware, I think because optical fiber sensor is having distinct advantage right? It's a very, very small in the size, very reliable, much economical. So if awareness come, I think it will be used in the large numbers, in the big quantity. You know, we have 1/6 of the world population, so our market is also big. So only thing is that somebody has to approach market correctly. It will be used in the big numbers.
Okay, thank you, sir.
Thank you, sir. Actually, sir, one another question from our UG 6 student, third year student of BSc Physics, Saurabh Rudra. I think Saurabh, you got your answer. He is asking that I wanted to how big is the optical fiber industry in India regarding its total market sales and service. So he's asking for some sales and service matter, some statistics maybe.
Right, I don't know the numbers, but I told where it is being used and where it can be used. So I don't know the how big is the. Of course, optical fiber and telecom. It's very, very big, right? Sensor is started. So I don't know market numbers, but yeah, a lot of opportunities and lot of use is already there.
Sir, also today we have Shomendranath Roy, sir. She is actually Professor Emeritus of School of Engineering and Technology. He is here and he wants to share some thoughts. Maybe. Sir, are you here?
Thank you, Papia.
Yes, sir.
Is it
Yes, you are audible. Perfect.
audible? Okay.
Yes, yes.
Thank you, Papia.
Yes,
And
sir.
thank you, Mr. Mehta. So, on this discussion, I have just one query. That is, we are going to plan to produce the green energy. Okay.
Right.
Green energy. Green energy from the seawater. Right. So in that case, how we can utilize this optical fiber? If you have some, you can give some enlightenment on this, then that would be good for us, so that we can utilize, or we can take your help to, I mean, what it is called, investigate these things.
Yeah. So optical fiber, see, which is the biggest source of energy in the world? Which is the biggest
Yes.
source of energy?
No, actually, we are planning, rather, we have started work to produce the green energy.
Yeah, that's
from
what
the
in that
seawater.
context only I ask, which is the biggest source of energy?
Yes. So how we can utilize this optical communication fiber in this area?
Yeah, right.
This is
So
one,
that's,
this is one question. And another inquiry is that nowadays there are a lot of handmade or portable, that is called the the instrument to identify the different constituents of elements within the wastewater. Okay.
okay.
And the turbidity, then pH, then conductivity, and all these things can be measured by a portable instrument.
Right.
So in that, there is not there using the optical fiber communication, optical fiber. So we are planning to do some optical fiber to utilize for this, making this instrument, so that it can be handy.
Okay. Yeah. So I will answer your question. First thing you ask about the green energy. So I was asking which is the biggest source. The biggest source of energy is the sun, right? Sun is the biggest source of energy in the world. Everything. So if you harness the sun energy, most of sun energy is wasted, right? So, so we are already, you know,
I must mention here,
yeah.
our production, fuel production would be hydrogen. Okay. The electrolysis of water, the seawater, to get the hydrogen. Already we have obtained, but that hydrogen is in the compound form.
Right.
So we are planning to do further work. But in this case, how we can utilize this optical fiber?
Yeah, so I am coming to that. So one one application, you know, solar cells, and we can harness the solar energy to get the
Yeah,
electricity. That is the one
that is
application.
the green source, green energy. That is the
Yeah,
green
yeah,
energy. Okay,
I
fine.
am just
Yeah.
allow me to complete. So the other thing, see, solar, there is a lot of power using the optics. Using the optics, you can get the sunlight. And if you use the optical fiber, using optical fiber, if you can bring the sunlight inside the house, inside the
Mhm.
pavement, inside the building, it will be
Mhm.
a very, very big source of the green energy, right? In the daytime, many of the places you can't get the sun, right? So if we can harness the sun energy using the principle of physics of the this lenses and mirrors, and take into the optical fiber, you can save a lot of energy and a lot of electricity bill as well. And plus, sun energy is very good. Solar is very good for your health as well, right? So
No,
there
no,
is a one application you can work on that.
sir, for the electrolysis, we are utilizing the solar energy, okay, or wind energy
Hmm.
for the electrolytic process.
Right.
And from that process, we are producing the hydrogen, and that hydrogen is not producing alone. That is in the compound form. Some other chlorine gas is present. So we
Hmm.
are trying to separate that hydrogen from that compound gas composition.
Right.
So how we can, my question is that how we can utilize this optical fiber to synthesize this process. Is it possible to utilize this optical fiber?
This must be possible, but I don't have direct answer. I don't know how exactly. It is possible, but I don't know how exactly. I have
Yes,
to do some
yes.
research on that.
Yeah,
First thing,
furthermore, I need your help.
yeah,
Okay. And I will contact you through Papia. Okay.
sure.
Thank you
And
very much.
second,
And the second, huh?
yeah, second question is regarding the medical application. Yes, medical application, optical fiber is being used right now also in India in big way in the gyroscope. You know the
Right,
gyroscope,
right, right,
they use the bundle of optical fiber to
right,
put inside the stomach and find out the many things, even cancer cells and all these things. And
right.
people are trying, IIT Delhi is working on this cancer detection device where instead of the doing the lot of surgery, just put one small optical fiber and find out the cancer cells. So yes, there is an application of optical fiber in the medical application, big applications, but somebody has to really work and commercialize it. That is a challenge. What happened in the India, people, most of the students after coming out, they want a white collar job. They don't want to do some research and try to make something. They just want to,
Right,
whatever somebody has made, they just want to sell it or manage
right,
it. That is a problem,
right,
right?
right. So actually, your process, where from you have purchased
Which
this
one?
process? What process you have discussed?
Yes.
You have video. You have shown the video.
Yes.
That process, where from you have purchased?
This
You
is
have
our own
developed
made device.
indigenously? Huh?
This is our own device. This we have designed from the scratch in the India itself.
Okay, fine, fine. With the help of someone or alone?
No, no, alone. We have done that thing
Oh,
alone.
good, good. Very good, very good, very good.
Yes, sir.
Thank you, thank you,
He's
thank you,
very
Mr. Mehta.
special in
Yeah,
this field. And Mr. Mehta has done a lot in this field, I can say. And
thank you,
yes,
thank you.
definitely. And as Sir told, as Roy Sir told, this is the utility and this is the aim of this kind of discussion, that we can contact you, the industry person, and we can do something as it is applicable area. Sir, one last question from our student or participants. That is, sir, is there any near possibility that APOPIDS can allow to extend itself to real-time imaging, full 4 pi angle around the source of detection? This question is from Jyotirmoy Khandra.
Right now, what we are doing right now, this FOPIDS is just giving the vibration detection. But what we have done this thing. We have integrated camera with this, right? So whenever detection happens, camera zooms and take the image. Like that, we are doing the image capturing right now. Because optical fiber is inside the cable, so it cannot detect the image directly. So that's what we have connected a camera with the system, and whenever intrusion detection, it gives this signal to the camera, and camera will just focus and take the picture. that is possible, and we are doing that.
So thank you, sir. Sir, I have one query that, like
Yeah.
me, who wants to do some basic lab in our institution. So, is there possibility to get some funding from this industry partner? Whatever you show, you have shown a lot of industry who is working on optical fiber. So, is there any possibility to get a small fund to grow on lab?
I am not sure right now because we also need funding to develop newer things. But yeah, we can help in the terms of the consulting or suggesting where to buy cheaper one. And there are a lot of government funding. We can help you in the applying for the available government fundings.
Yeah, yeah, there is something that with partnership with some industry, we can apply some funds.
Yes, there is a lot of
That
funding
can,
available from the DST, DSIR,
yes,
and this kind of agencies. You can even Bhabha Atomic Research Center, they also
yes,
fund. So we can help in that. There is some
thank you.
question from the Tamal
Yes,
Mukherjee.
sir. Yes,
Yes.
Tama, sir, please.
Am I audible?
Perfect.
Okay, sir. Is this forfeits devices available for personal use? I mean, can I install it in my homes, for example?
Why not? Why not? We'll be very happy.
So I mean, so how to get it? I mean, it's not available. As I searched in Google, but I could not find any marketplace to buy it from. So where is
You
it? I
can
mean,
directly buy there is, if you search in Google for MOP IDS, you can find our company. So our company, there is a contact number and everything is given. Or you can
okay,
contact me. I will put in touch with my sales people,
okay,
and
okay.
we'll give you on the very good rate. You can use, you can see how it works.
Yeah, I'm very much interested, sir. And sir, another thing is that if suppose some of our students are interested to work as internship in your company, is it possible? I mean, they can apply.
It's a work, but our factory is in the Madurai. If they are ready to go to Madurai, definitely we can look at that.
Yeah, I will ask them. I mean, if they are interested to learn from the industry expert, then it
Yes,
would be, I
yes,
think, very, I mean,
yes, yes.
good opportunity. Okay, so they can, if they are interested, they can apply. That is
Correct.
your message, right? Okay,
Right.
thank you very much, sir. Thank you very
Thank you,
much, sir.
sir. Thank you, sir. And really, I got some very important and impactful suggestion from you that how to means if I want to expert in optical fiber sensing in, industry, then how to construct our how to grow our curriculum. And I would like to say, unfortunately, our university, our Department of Physics has already started some this kind of means application-based version like AI and all deep learning and all in our syllabus. It is compulsory now.
Whenever you make the curriculum, you
Mhm.
put some industry person in that committee who
Yes,
can give you
yes,
suggestion.
yes, yes.
Otherwise, if only academic people will make, they will not know what to put or what not to put, right?
Yes, that we will be trying to do so, and we have always a basic electronics and advanced electronics in BSc and as well as
So
MSc.
now everything is become multidisciplinary. If you see any field, you
Yes,
require
yes,
knowledge of everything. You can't just
everything.
specialized knowledge. You can't do anything. So physics, electronics, software, all things are combining now. Even in the IITs and many other foreign institutions, they are giving knowledge of everything so that people can go in the industry and work really in the some useful thing.
Yes, sir. Yes, I can understand. Okay, so it was really nice to talk with you, sir. It was a really good interaction session as well. Last, if anyone want to ask anything, otherwise I
I
will.
find that students are not asking anything. They are very shy, or how it is.
Maybe students are like that only.
No, I would like to tell the students that whenever they get the opportunity, they should ask as many as questions as possible. They should not feel shy. If they want to really progress, they should not have this kind of inhibition.
Yes, you should ask students. Only deep ask and some other.
No, I mean, three of our students has already asked.
You
So other
already asked.
students are should, I mean, also come forward and ask whatever in your mind. There is no stupid question, only
Saurabh,
stupid
Yeah.
answers.
Yes,
So
yes.
I
three
mean,
students
Very good.
already interacted. So, if anyone of you want to ask anything,
So what courses you give? BSc Physics, MSc Physics?
Yes, sir. BSc and MSc in physics and PhD. Right now, we have only 3 programs running on in our university.
You have
But
anything called applied physics also, or only pure physics?
not applied physics, but we have some value-added course and minor courses where, I mean, those courses are designed with the application in mind. I mean, suppose, for example, engineering departments can offer some value-added course or minor courses. Application of AI designed to, I mean, those courses are designed, suppose, for example, keeping in mind the need of the students of physics background or science background, something like that. And
Right.
we have designed some courses which will be useful for the engineering students as well. So
Correct.
these
So,
value-added course and minor courses are there, but not application applied physics program.
yeah, if you can make a program or change the degree name like a BSc and MS in applied physics or engineering physics, they will be having better job chances in the industry.
Yes, sure, sir. We will consider, sure. Maybe I mean, if you have time, would like to, I mean, invite you to our campus so that we can have an elaborate discussion on that, what can be done. I mean, so
Yeah,
this
surely.
kind of communication should, I mean, would be very great, useful for us.
Where are you located? Near Calcutta or?
Yes, near Calcutta Airport,
Okay, okay,
towards the north.
okay.
Yes, sir. Maybe we will have coming conference, national conference, and some workshop uh, that time or any time for this curriculum discussion. We will be invited. If you have the time, please come and visit our campus.
Sure.
Okay, so I think there is no such question. So students and also the other participants who are here. So please write to me. I can communicate with Mr. Mehta regarding any point. So now this is the time to thanks everybody who was associated with this webinar. I would like to thank our speaker once again to share thought on education, research, connection with the optical fiber industry, real-time application of optical fibers as sensor, career opportunity in this domain after graduating with PhD or MSc degree, and the real market for optical fiber sensor, etc. So as I have a big knowledge on this area, I must say that it is a great contribution for the educator like me as well as students. Uh, I would like to thank all the participants, our respected Dean Sir, Professor Pandit Sir, for his encouragement for this kind of meet. Like to thank our HOD Madam for her support. Thank you so much for the participants. Special thanks to our current coordinators, Mr. Mohit Shaduka and Dr. Kumar Mukherjee. And last but not least, thank you so much to our IT team, especially to Mr. Ranabhrata Chanda. And we are really grateful to Mr. Chandrashil Tiwari for this night digital fire. So we are at the last and almost in the end of this our session. So if there's no other query, so with a positive thought on uninterrupted skillful learning and broad career path, I'm concluding the session here. And thank you so much once again, all participants and obviously our speakers for this nice talk. Thank you so much and have a nice day. So much, everybody.
Thank you.
Sir, thank you so much, sir. We will contact you again for further, I mean, regarding the research or any issue, whatever we will.
Okay, okay. Thank you. Bye.
Okay, sir. Thank you so much, sir.
Papia streaming can be stopped now, I think.
We can stop recording.